And this will factor into n plus 5 and subtract 2. Now, when it works out like this, the way it worked out on this one, it's nice because I see this n plus 5 shows up, and I see n subtract 2 shows up. And when they match up like that, that's a good thing. Now, step 1, with that factoring done, now we'll take his advice he gave me. He's asked me to put now everything over a common denominator. Guys, what should my common denominator be based on what you see up here? What would you like to have? All this on the left-hand side, well, all these fractions. What would you like to have underneath in that denominator? All those fractions to have.
N plus 5.
N plus 5 times
N
n subtract 2. The first fraction has the n subtract 2. It's missing, I don't have this for my common denominator, it's missing the n plus 5, so I'll put that in right here and here. My second fraction, 3 over n plus 5, easily seen, it's missing n subtract 2. Just gotta be patient, put it in. The last fraction has everything it needs. Nothing to be done there. Now all I need to do is clean this up and be very careful. Left-hand side, distributive property on top there, my numerator, 2n plus 10. No problem. Numerator, second fraction over there is 3n subtract 6. No problem. And on the very end, 10. Is that true? Who on earth? You know how math is. Who on earth would have thought that that crazy equation in the black there is saying this? So, Professor, why don't you give it to me on the test Wednesday, quiz Wednesday? Why don't you give it to me like this to begin with? Don't give it to me in that black form up there. Give it to me like this. No, it's no fun. That's why I should clean it up. Now, guys, can I clean this up further? Well, I could write this as 2n plus 10. And being very careful, I could collect my numbers on the right-hand side and call this 3n plus 4, making 6 plus 10. Still amazing. We start out with the black. We're down to this. Now to solve it, easily done. Guys, I'm going to move this over by subtracting and end up with the negative 1n. I'm going to move the 10 over by subtracting on both sides, and 4 subtract 10 is negative 6. Let's move things around. Solve a simple linear equation. Divide or multiply by a negative, will quickly turn into n is equal to 6. I think it's the same thing we got in class last week. Now, here's what my 4 o'clock session student was asking after we finish up. Please, I take note of this. I'll have this on the quiz. Are there some numbers back in the original black? Look at the original black. Are there some numbers that if I should have gotten them down here, I definitely could not use them for some reason? In other words, n could not be, name the numbers that I would have to reject if I should have gotten them.
5 and negative 2.
So again, I stress my students in that 4 o'clock session. What numbers are based on black for the n? If I had gotten that number, I would have to reject it quickly. I see a hand going up, yes.
2 and negative 5.
Thank you. And tell the class why 2 and negative 5.
Because they,
If I go back and place n by 2 right here, what are you going to end up with for a denominator?
0.
0. You can never have a 0 denominator. Mathematics, impossible. Go to grad school, still impossible. He also gave me a negative 5. Why? In this fraction, replace n by negative 5. Negative 5 plus 5 gives you what?
0.
0, impossible everywhere. Now, did I get either one of those down here? No, so I feel good about this answer. Now, am I going to do a full check here? I'm not going to do a full check. You may want to check yours on the quiz Wednesday. But I think we got the same answer last Wednesday. N equals 6. Okay? Look good? Now, part B. Just a little connection to what we were doing last Wednesday. Now, let's see if I can move this, so I can, into this. Square root. 2 subtract 2x plus 2 is equal to x. Let's solve for x. Real quick, this is going to be a mixed number of problems, mixed up. May have a square root in it. No common denominator here needed. Now, what would you suggest now, since you see a square root staring at you, what might you want to do?
Square both sides.
Now, I'm not gonna square both sides right now.
Then with the 2 to the subtract it.
Yeah, you better isolate, they use that word in your textbook, you better isolate that square root first, get that square root part by itself. Then I'll take that suggestion of squaring. I got step one, I'm gonna leave this square root all by itself. Move the 2 over, in other words, subtract. Now the square root part has been isolated. Now I'll take his suggestion, which was do this, square both sides. No problem. Left-hand side's gonna be nice. When you square that square root, the square root drops off and leaves you merely that, which is cubed. This, be careful. I gotta square the other side also. What's x subtract 2 times x subtract 2, or x subtract 2 squared gonna give me? X squared, help me out,
X squared
minus 4x plus
4.
4. Now please look at the red. That's why I like to use these different colors. Look at the red. Here's the black. That was the original, we changed into this. There's no square root now. Now, let's see what I have here. It looks like it's gonna be a quadratic. So let's put one side to be a 0, everything else on the other side. Guys, I'm gonna move this over. And I'm gonna move this over. And I'm gonna have a 0 on the left. We end up with x squared. I think when I move this minus 2x by adding, when I get here, negative 4x plus 2x, when I move it over. I think it's a negative 2x put together. And then I think I have, what did I think, let's see, yeah, 2. Then 4 subtract 2, when I move that 2 over, it's 4 subtract 2 gives me on the end what?
Plus 2.
Plus 2. Yes or no?
Yes.
Woo! Don't let me make a mistake here. Now, I'm looking at that, it's getting scary. Let's make sure everything's right. Everyone agree with that so far? Look good? It's a quadratic. I would try maybe what, factoring? Use the quadratic formula, is that true? Or eventually we'll show you this completion of the square we were talking about last Wednesday. Guys, on this one, if everything's been moved over correctly and everything's been done correctly, now I'm looking at it carefully, I think x squared minus 2x plus 2 looks correct as a factor. Forget it. If I try quadratic formula, there we go. X is equal to negative b, just a reminder, plus minus this, all over this. We all know how that quadratic formula works. So guys, we end up with negative and negative 2, that's my b, plus minus square root, b squared to negative 2 squared. Subtract 4 times a is a 1, c is a what? 2? All over 2 times a, which is 2 times understood to be a leading coefficient, a out there is a 1. Now, round up the board, make sure I put everything in there correctly, guys. Does it look good? Yeah. Look good? Now try to finish it up. This is a negative 2 plus minus. Now, underneath that square root, I know and you know negative 2 squared is 4. Is that true? I'm back to the side of positive 2. This is a positive 2 in here. Out front. Now, plus minus. Underneath there, I see 4. I think 4 subtract 8. Yes? No? Is that negative 4?
No, that would be,
Is it negative 4?
no, it's just 4 because the.
Is it
No.
4 subtract 8? Underneath there. Is it 4 subtract 8?
Yeah. Yes.
That's what I checked. I think 4 subtract 8 is negative 4.
Oh, yeah,
Don't scare me. Now what's wrong? What's wrong? And I hope we don't have a mistake in this. Rams, why would you bring something in like this in here?
Have a negative,
Can I take a square root of a negative?
no.
Not unless you go into those little numbers called what?
Math
Imaginaries.
Imaginary,
We
yeah.
haven't discussed imaginaries, the I. So at this point, you're going to say, no solution. Professor, I tried, but I ran into something, a difficulty. I cannot do a square root of -4. Now, some of my students may see what it should be when we finally go into imaginaries. Does anyone just out of curiosity think square root -4 could be expressed as, in the future, as what? 2i.
2i.
Square root 4 is 2, and then the I there, 2i. That's not what we're looking for on that quiz. So if I ran into something like this, you say, oh, look at all that work we did, Professor, and nothing worked out. That can happen. We tried, it just didn't work out for us, so there's no solution. That's the reason I brought this in. It can happen on Wednesday. Now, that's how my students on that first quiz. I know how students, when you go outside, you'll start talking. What did you get for number 2? I got 3. What did you get? I got -8. What did you get? I got 16. And then rush back in before I leave the classroom and say, Professor, I can't answer that one. No solution. Oh, you missed it. So some of these might come out to be no solution on the quiz. So be aware of, just in case things happen. Okay, letter C. For a reason there, just to point that out. Letter C looks like this. Square root, there's square root, 3x plus 1. Subtract. Square root x minus 1 is equal to 2. What's the solve? Make sure everything's copied down correctly. You guys in the 4 o'clock session, remind me, is this the same problem or not? No, I made a different problem then. Does it contain square roots? Like the last one? Yeah, the last one had a square root. This one has what? 2 square roots. So that means I want to square both sides eventually, probably twice. Now, to get a start, anyone tell me how, and let's hope this one works out and gives me answers. I hope it's not this. No solution. Anyone tell me what you think about it, just the way it looks, and I will tell you ahead of time. You can't do this, I'll tell you what you can't do. Don't do that.
No.
No. Don't do this. This would be worse. Not valid. Not valid. Now that's tempting, because now I see a square root. Professor, I want to get rid of it. Square it, square it, square it, square all of them. Not valid. Now, can anyone tell me what, since I've shown you what you cannot do in step 1, does anyone have a suggestion on what you might want to do in step 1, and then we'll apply that squaring? Let's mess me up here. See a hand going up. Yes?
Couldn't you combine like terms, so it would be just 2x once you, it would be square root 2x?
Oh, I can't put them together. I see what you're saying. You're saying put these underneath here together, and the ones cancel, and you end up with probably, I see 3x minus x in his mind there, 2x. Wish I could, can't do it. I cannot combine those parts underneath there. Oh, I see a hand's going up. Let's try, yeah.
Do you add square root x minus 1 to the other side?
She says, Professor, isolate. You've got 2 square roots on this one. The last one had just 1 square root. Did I isolate my way? Did I, on this, back here on the first one, did I actually get that square root all by itself first? So she said, wait, since you have 2, you gotta do the same thing, Professor. Get one of those by itself first, like you did this one. Then square those sides. So in other words, I'm gonna move this one over. Let me erase these. And she says, Professor, leave this square root where it is, all by itself. Well, a little strange. Move the other one over, and you end up with this. Now can I square both sides?
Yeah.
Yeah, for sure. On the left-hand side, it's cute. Square this, no problem there. Right-hand side may take a little effort, but we'll do it. Left-hand side is beautiful. She's going to get 3x plus 1 in no time. Now, the right-hand side bothers me, because I gotta square it also. Now, guys, you could, I've run this up to the 4 o'clock session, you could think of this 2 plus radical x minus 1 as taking the form of, back in algebra, when your teacher asks you to square something that looks like that. This sort of looks like this. From algebra 1, I think they teach algebra 1 now in 3rd grade. Does anyone remember what a plus b quantity squared was back then? A plus b times a plus b. Just out of curiosity. A squared
Plus 2,
plus, I hear it, plus 2a what? B plus
B squared.
b squared. If you'd like to apply that from algebra 1 on this, where the a is 2 and the b is that square root, and just plug in here, and you'll get the expansion. Other students may say, well, professor, could I do it like this? Here's another option. Could I set this down twice? Like this. And use FOIL. One of my 4 o'clock session students use the word FOIL.
Right.
FOIL it out, expand it out, you can do that. So you can either write this down twice, and FOIL it out, or expand it out, or use this technique here. Either way, guys, anyone tell me what are you going to end up with? 4 definitely. A squared, where a is 2, 2 squared is 4. Now be very careful what you think 2a times b will give you if you're using this like formula. What will that give next?
Because that would be 4x minus 4.
Tell you again.
4x minus 4.
4, hang on up, 4 square root x minus 1. That's what this would give you. You'll get the same thing if you use FOIL. Now what do you think the b squared on the end is, where b is square root x minus 1 and you're squaring it?
Yes, it's
Ah.
What are you going to end up with? Go for it. X minus 1. Square root drops off. You'll get the same thing if you use FOIL. Or expand this out. Now, I love that, what she suggested. Do I still, though, at this point, still have a square root, another square root still remaining? This thing had 2 square roots. Do I have one still remaining?
Yeah.
So I gotta do what she suggested at first. Again, I've gotta get this remaining square root term isolated, all by itself, and then I'll square both sides again. This is lengthy. Now, how am I gonna do this? Gotta move things around. 3x plus 1, let me use my colors here. 3x plus 1 we have here. On the other side, I do see 4 minus 1, I can put those together, that's 3. Plus this part that I'm trying to isolate a little bit later. And then go inside a plus x. That's cleaned up a little bit. Now if I want to isolate it, that means I gotta move this 3 over by subtracting, and move this x over by subtracting. I think, help me out here, I think you're gonna end up with 2x minus 2. Do not let me make a mistake. And do we still have this? Yes or no? We're gonna move terms around and clean it up. Now, is that last square root term all by itself now? Is it isolated? Guys, I'm ready to square both sides again. Now, anyone in this class, and I've been bragging on you guys already. Some of my colleagues have already given quizzes in their classes. And they were just shaking their heads like, whoa. Francie, have you given the quiz yet? No. Why? Ooh. Ooh. So I don't wanna go, ooh, next Wednesday after I score yours. Now, I am gonna square both sides. I can square both sides right now, but we lucked out here. Sometimes you look out. Anyone tell me something I could do before I square both sides, which might save me a little time?
Can we divide by 4?
Thought you had it, not 4.
Can we take 2 out?
Take 2 out or divide everything by 2. Now, by the way, will both sides be divided by 2? Is it possible? Could I divide left-hand side by 2 and quickly get x subtract 1? Which is, I think you should deal with it. The other side divided by 2, 4 divided by 2 gives me a 2 rather than a 4. At least it's a smaller number. I just divide by 2. Sometimes you luck out, sometimes you don't. We lucked out here. And now, I'm gonna use what she suggested way back. She said, wait, Professor, you got a square root, you gotta do this again. You make the square both sides. Wow, what a problem. Now, anyone tell me right quickly, x subtract 1 quantity squared would give you, x subtract 1 times x subtract 1 would give you x squared minus what? 2x plus 1. Anyone tell me what the right-hand side would give me? When you square, I see a 4 for sure. And then the square root's gonna drop off. And distributive property, what will all that give me?
4 to 4.
Now here, 4x minus what?
4.
Look at that. Now, here we go. Me. With all the math I've had, and I got a lot of math. You stop me on campus, say, Professor, I got a problem. I said, what's the problem? Here it is, Professor. You think professors stand on campus, walking to class, would I know? I don't think any professor would they know that this is equivalent to this? Immediately. I don't think not immediately. You get that cleaned up like we did here. Who would think those two are equivalent? The square roots are gone. By the way, this one turns into a nice little quadratic. Now let's move everything over to one side. Do not be messed up. We end up with x squared subtract 6x plus 5, yes or no?
Yes.
Just move everything over. Now that has now turned into a what? Quadratic. To solve it, you guys who like quadratic formula, go for it. I think this one though will factor. Of course, it's a little bit quicker, but if you use quadratic formula, at least we'll factor into x subtract 5 times x subtract 1 is equal to 0. Split this up, called zero product property. Set each one of these factors equal to 0. That's why that 0 is so important. And you end up with 5 and a 1. Ah, so this one had answers, this one had none. Now, I'll do this. The original problem. We have, right now, for consideration, these two answers. Now, to help you out on the quiz Wednesday, when you see one of these square roots, and you will see one on the quiz, I more than likely will require you to show a check. Especially if it has a square root. You gotta show me a check, because it may not work. Now, let me show you what's happening here. We took each side, left-hand side, right-hand side, through this, and we squared both sides, squared both sides, we're gonna square both sides. Please tell me from basic math, if I gave you that statement, if I say -4 is equal to a 4, is that a true statement or a false statement?
But it,
Is that a true statement right now that you're staring at? Is -4 equal to a +4?
No.
I see on campus, no one, some of my students, previous students, when I see them on campus, I saw a couple last week, parking in the parking garage. They know me. If you see me on campus, I'm asking a math question. So all they did was, Angie gave me a wave. I said, come here. No, I'm asking a math question. If I see you guys on campus, I'm gonna ask you a math question. Forget the hello. It's a math question. This statement, that is just on the side. That has nothing to do with this problem. This is a false statement.
but we could make it.
It's a false statement. If I do this to it, as we were doing as a process down here, now does it become a true statement? That's the trouble with those that contain square roots. Your answers may not work. In fact, in this case, it did not work. Or one may work, both may work, none may work. All because of that squaring business. This could be the original problem, which is false. After you square it, you turn it into a true. That's what's happening here. So somewhere in my process, when you square both sides, you may be changing the form of the original into a true. Guys, let's try this. I'm gonna check it. What about here? Okay, first, I want to check, where am I anyway? 5. I'll put 5 in to the original. Square root 3 times 5 plus 1, subtract, square root 5, subtract 1. I'm hoping that will give me a 2. If not, I have to reject that number. Guys, I think this is square root 16. Subtract square root 4. I think this is 4 subtract 2. Check. So the 5's an answer. Now, the 1 came out the red there, may not work. Who knows? Check it. And guys, to check it back in the original, 3 times 1 plus 1, subtract square root 1, subtract 1, and we're hoping to get a 2. Make sure I put all that in there correctly. I think I did back in the original. Okay, we did. Guys, this is square root 4, square root 0, 2. This is 2 minus 0 is 2. Check. This time, we got 2 answers and they're both checked. Last time, this thing right here, nothing was. They said, Professor, do I know ahead of time? You do not. You will not know ahead of time. You just gotta jump into it, try it, and check the answers. Guys, look at this carefully. Any concerns here? What's going on here? Okay, solving equations. I have a nice quiz for you guys Wednesday. Okay, next one looks like this. I brought some nice ones here today. Oh, here we go. Letter C, D, I guess. Put that right here. Maybe moving something else here. 3x cubed plus 4x squared equals 27x plus 36. Let's make sure all that's copied out correctly here. Okay. How many answers are you expecting here? 3. 3. We're expecting 3 answers. Now, if anyone give me a suggestion on what you might want to do first, at least it does not have a square root. There is no square root on this one. Give me a suggestion.
Start factoring out.
I could. I definitely, absolutely could. Before I start factoring, might it be wise to do something else? And sometimes you don't know, you jump into it. Go for it.
What about, is it like the x, to the, move to the what side?
Okay, we'll move everything to one side.
Mm-hmm.
Okay, let's do that. Then we'll take his suggestion. Okay, move this over, and she's suggestion that I write this as 3x cubed plus 4x squared, subtract 27x, subtract 36, equal to 0. Which is true. I like this problem. At least no square root. I'm expecting 3 answers. Now, I heard the word factor. How am I going to factor this?
We can do grouping.
Thank you. There's a key word here. About 4 terms. She's down to professor. If you're careful, you might want to consider just the first 2. Do what you can do with it in factoring. And then, professor, maybe consider the last 2. It's called method grouping. And when I group the last 2, like this, let's do it. Now the red, what type of factoring can I do in the red?
Excellent.
Is it a common factor?
Yeah.
X squared.
Nine.
Is there an X squared? Let's pull an X squared out. And you end up with 3x plus 4. That's the red one done. Now the one in blue, here's the blue. Be careful, someone be clever for me. Does anyone see anything I can do in terms of factoring it?
Take out a 9.
Oh, look at that. Take out a 9. It might be wise to take out a negative 9. I'll show you why. If I take out a negative 9,
Because they're both negative.
there you go. Take out a negative 9, that's 27. Almost erased it. Pull out a negative 9, guys. Please tell me the blue will I end up with 3x plus 4 again. And that's equal to 0. Yes or no? Now what in the entire problem, the red and the blue, we're not quite finished. Now what's happening between them? Go for it.
Now we can remove the 3x plus 4.
Thank you. There's a common factor of 3x plus 4 in both. Take that out. 3x plus 4 is being taken out, leaving an x squared for the red, and leaving a 9, subtract 9, for the blue. What a cute problem. Factoring, factoring, factoring. Now, does anyone recognize what x squared subtract 9 may do for me in terms of additional factoring? What will that do for me?
X plus 3,
You got it. 3x plus 4, and she's telling me x plus 3.
x minus.
X minus 3 is called difference of squares. Look at that problem. Now split this up right quickly, guys, and save me a little bit of time. You know what to do next. Split each one of those up, solve. I think you'll end up with x to be a negative 4/3 here. I think you'll end up with a negative 3 here, and a positive 3 there. Did we get 3 answers? Did we finally get 3 answers? Okay, let me list those in a set. We have negative 4/3. Looks like a 3, negative 3, and a 3. And those are my 3 answers. Now, am I going to check all 3 of those? No. I just have limited time. You should always check your answers. Looks good? We got 3 answers there. Okay, now if you walk in here Wednesday, and you say, wait, Professor, suppose you give me this. X to the 10th is equal to 1. We're supposed to get 10 answers. Does anyone think they know what? I'm just throwing it out there. What the 10 answers may be? 1. 1 raised to the 10th. 1 raised to the 10th is 1. 1, that 10 answers. I think there's another number. Is it negative 1? Well, negative 1 raised to the 10th, negative 1 times negative 1 times negative 1 out 10 times. Will that finally give a result of positive 1? So 1 and negative 1, that's 2. Can anyone think of another number, real number, that may, when you raise it to the 10th power, give you a 1 besides 1 and negative 1? Besides those 2, 1 and negative 1. I don't think so, not for us. Right? Well, let's just get 10 answers. What do you think that 1 and negative 1 would do for me? What do you think they will do for me so I count and I'll have actually 10 answers? Would those answers repeat somewhere in my process where they actually repeat?
Yeah.
Maybe you have 1, 1, 1, 1 5 times, and then negative 1, negative 1, negative 1, negative 1, 5 more times. And those are your 10 answers. You have some numbers that are multiple answers. That might happen on this. I just thought I'd point that out. Guys, I'm pretty much, I think, I'm gonna check the time here. Yeah, beautiful. I'm feeling good about this. Is it gonna take some prep time? It is. On your part. I think I'm basically almost done solving equations. I'm going to solving inequalities. Go for it.
Is that a x equals negative 4? over three?
We're gonna find what?
The bottom right.
Way down here?
Yes,
Negative 4/3.
the negative four, okay.
Is that what you're looking at, right here?
I couldn't see the negative sign.
Yeah, sorry, yeah, negative 4/3. Go for it.
I wanted to ask what happened to the other 3x plus 4 earlier in the equation? You removed one and then it became 3x plus 4 and then x squared minus 9 right there. I didn't understand it, that's why I was wondering.
Oh, you mean down here?
Um,
Are you talking there?
the 3x plus 4.
Oh, I got you, I think you're looking back up here.
Yeah, right there.
Yeah, yes. All I did was, I took out a common factor of this. This shows up in both of them. So that's my common factor right here, 3x plus 4 is in common with both of them. So I pulled it out, and that left x squared, subtract 9.
Okay. Thank you.
That help?
Yeah.
Hang on. Before I do this. Guy, look at this. Can you see it over there?
Yeah.
Suppose it looked like AB plus CB.
Yes.
Tell me what you could do there.
I'm sorry?
Yeah, factor that for me. What could you do? Do these two have something in common?
Yeah, the B.
You take the B out. That's what I was doing here. And then you're left with what? A plus C. That's what I was left with here.
Oh,
And a
okay.
common factor.
Thank you.
Guys, anything else? Now, I'm checking my notes here. Let's see if I'm ready. Beautiful. Beautiful. Now we'll do a few things with completion of the squared, and that's basically solving equations done for us. Now I promised you, I think last Wednesday, I think that we at SMC should be doing, if they offer a pre-calc class at UC San Diego, or UCLA may do something with pre-calc, something online with students, I find out what they're doing. And I take questions that they have. So sometimes these quiz questions will be UCLA caliber, UC San Diego caliber. I've actually used, where's Mr. Park? Oh, there, he's busy. I reach out and try some of those universities, don't I? As long as you've been with me, yeah. And sometimes I'll put on the side there where I found it. UC Berkeley. I'll let you know where I found that problem. You say, Professor, they're doing some of the same stuff. They are. Now, they're gonna move faster at those universities than we are here. Of course they are, because they got so much more to do in that course. But if they do it there, we should be able to do it here. So you guys, we slow down here. I'm looking, and here's what I want to do. All this next part, which I'm so glad we knew. Now watch carefully. I think you're gonna like this. And that is, I guess all this is in part 1. Let's call this part 2 then. I think it's part 2. Solve. Now, I follow the first this. Beautiful. This quadratic. X squared times 6x plus 4 is equal to 0. Watch. Okay. If you see that, I'll just say solve. And I'll tell you ahead of time, this one will not factor. This one you'd have to turn to, more than likely, most of us would turn to the quadratic formula. And say, Professor, my goodness, just plug those numbers into the quadratic formula, crunch it out, and I'll get an answer. Guys, let's do it by quadratic formula first. X is equal to, here, go real quickly, negative 6, plus minus square root, negative 6 squared, 1 times 4 all over, and please make sure I have all my numbers put in correctly into that quadratic formula. Looking at from here, I think everything's good. X is equal to 6 plus minus square root. Now guys, underneath that square root, on Wednesday, be careful. I think this one says 36 subtract 16. I think. And 36 subtract 16, 20. All over 2. Cute problem. X is equal to 6 plus minus, too bad that's not square root 25, it's square root 20. Can I simplify though? It will not be perfect, but can I simplify square root 20? Into
2 square root.
2 radical 5. Thank you. 4 times 5. All over 2. 4 times 5, square root 4 is 2. That's where I got that 2 radical 5. Then these can be all simplified or divided by 2 to simplify this. All right, this is 3 plus minus radical 5. And there's no mistake, you would list separated. Professor, one of the answers is this, and another answer is this. Plus radical 5, 3 minus radical 5. So you're done. You're finished. That's just really by quadratic formula. Now part B, I'll take you to some place we have not gone yet. Now, or I will ask you to help me. Now solve this. X subtract 3 squared is equal to 5. Now what might you suggest I do there? Solving another equation. Give me an idea, how would you solve the next one? This one.
Expand x minus 3.
There again,
Expand x minus 3.
he says, Professor, you could go ahead and expand that out, easily done. And when we do this is quickly, make sure my expansion looks good. Is that now that? And then more than likely, he would ask me next, maybe move that 5 over by subtracting and make this a 4. Is that what I originally had back here? Do you think you could have found the answers? We got the answers by a quadratic formula here. These are the answers. Could, if it had been presented to you in the black here, not here, this way, could it have been solved more quickly? Could you have ended up with these 2 answers in no time if I'd asked you to solve it in this form here, rather than what I gave you over there? Would have been a little bit quicker. What could you have done? We verified this. What could you do if it looked like that, maybe, to get the answers? Could I do a square root? If I did a square root, I saw a student show a square root. Both sides. Left-hand side is definitely this. Square root 5, can't do anything with it. It's not square root 9, it's not square root 25. Will not simplify, can't do anything with it. How many answers am I expecting? It's a quadratic.
2.
Yeah, so to show it's me 2 answers, you got to put plus minus, and of course that radical 5 stays like it is. The plus minus just shows I need 2 answers. Move the 3 over, add 3. Please tell me, are these the same answers?
Yes.
And I didn't touch quadratic formula. I applied the square root. So it would have been much easier for a student to get through if you were pacing with your time limit. Pacing yourself would have been much easier if I had given to you like this, and apply a square root on both sides, plus, minus, ensure you get two answers, rather than this process here. So now, what I'm gonna do here is letter C. Here comes the lesson. I'd like to know, how can I change this into that? Myself, you as a student, I can start x squared, subtract 6x plus 4. Now watch carefully. I'd like to change it for a reason. I'd like to change this into that. And I don't know whether I have some students in class right now who may have an idea. I see a hand going up in the back there. Yes, before.
You can do the completion of squares, so you can subtract 4 on both sides and then input a 9 on the left side.
Look at that. Hang on just a second. She's saying, Professor, you're leading us up into this process called completion of the square. She says, Professor, move that 4 over first out of the way. Move the 4 over. She wants all the x's isolated for some reason. Then she's saying, Professor, you need to complete the square, and I have not shown you much of the completion of the square. I'm going into that now. Guys, geez. To complete, she's asked me to do this. On the left-hand side, I'm gonna do it like this. She's saying, Professor, you need to complete, in other words, add something to it. But if you add it there, you gotta add it also on the other side. She's saying, complete that. That's what complete means. And then they have, in their expression, complete the square. So in other words, this has gotta come out to be, when you finish it up, a perfect square. That's what they call it, complete the square. Anyone tell me what's required on that blank? So the left-hand side will be a nice, perfect square.
9.
9. If I add it there, I gotta add it here. Keep the equation balanced. Now, what I write this now is x subtract 3 squared is equal to 5. Is that what we start out with up here? So if it were given to me in the original here, you say, Professor, could I change it into by this completion of the square that she helped me out with? By completing it, adding something to it, and make it work out? Why not? Okay? So I'm gonna make it a little bit easier for you. Let's go back to the original. Here it is, right here. Now watch what we'll do. I'm going to say, let's complete the square immediately on those x's, right there. And we'll add something, and I think we've already decided that we're gonna add a what? 9. But I'm gonna subtract 9 at the same time. Of course, I've got my plus 4 on the side here, is equal to 0. Now please tell me, it looks a little strange. Is all this mess right here equivalent to my original? Were the 9's cancel? Was that taken right back into the original? Which now gives me quickly x subtract 3 squared for this. These two put together is minus 5 is equal to 0. Move that 5 over. Am I right back into that? It's called completion of the square. Now, before I take questions, some students will remember, and some students will not remember. Does anyone think they realize how to come up with that magic number that you need to put in here that always works, so you won't sit there and waste your time trying to come up with a number? This one was pretty easy to see. But is there some little technique you could use to find that magic number that's needed to complete? I see some hands going up. I saw, yes.
It's always going to be half of b, which is
Process, a little technique.
Square.
Take half of this previous coefficient, in my case, half of 6, or negative 6. So we get 3, and then do what to it?
square.
Square it, and always do this. They'll always tell you what's on that end to complete. And you go from there and get the answer. Now, if that's true, of see my time here, beautiful. Part C. Let's try one before the break comes up. Completion of the square. You guys here, girls, let's see if I brought some nice ones here. I hope so. Hang on, hang on, hang on. Okay. X squared, subtract 2x minus 6 is equal to 0. Now, if on the quiz Wednesday I say just solve it, and I'll tell you how to do it, I think most students would jump into it at this point and say, Professor, I'm gonna use quadratic formula. It will work. It will work. If I say no, do it by completion of the square. You get the same answer. That would be this. Consider the x's. And then ask yourself, oh, Professor, you say complete. Yes, I need to add something to this. This is supposed to turn into a nice, perfect square. And then go from there. Guys, can anyone tell me first with her advice earlier, what might that number be on the end here to make it complete?
1.
I heard what, 1? Half of 2? It's half of this coefficient here, so you came to the little process. Half of that middle coefficient, half of 2, or negative 2 is what, 1, negative 1, but you got squared? That tells me 1 is needed, I'll put it right here. But immediately subtract 1, and subtract 6 is equal to 0. I think now that will take you back to the original problem. Will these eventually cancel? And will I just take you back to x squared subtract 2x minus 6? Is that true, guys? The way it's written? Will these two actually, in essence, cancel? And leaves you x squared minus 2x minus 6, which was the original problem. I just rewrote the original problem. Please tell me, again, before I do anything else, are these two statements equivalent?
No.
Will these cancel? Will these ones cancel?
Yeah.
And will that leave me x squared minus 2x minus 6? Is that what I originally had?
Right.
Yeah. So whatever that number is that she gave me to add, you got to immediately make it drop out or add the opposite of it to make this process work. A little strange. Now, what's going to happen now? Yes, with what she gave me, this is a perfect square. That's the whole purpose. That's why they call it complete the square. It's a perfect square. Here I got negative 7. I think. Is that true? And then to finish this up, you got x subtract 1 what? Squared. I'm going to move that 7 over. Now what would you do to finish up and get the answers?
Square root of
That's why we do it. Now you're going to apply square root. Square root. We're going to do more of these after the break. You're going to end up with x subtract 1 is equal to, make sure you put plus minus. You're expecting 2 answers. Radical 7 can't do anything with it. That's it's plus minus. Move that 1 over. Get the x all by itself. Those are your answers. And we did it by this process called completion of the square, which I'm going to do more of after the break. But before the break, we erase this, and I'll stop. You say, Professor, please give us a choice on the quiz Wednesday. If I say, here's the original. Now if I say solve it. I don't say complete the square. I say just solve it. And most of you would say, Professor, I'm going to do quadratic formula on this. As here goes quadratic formula. Negative b plus minus square root b squared subtract 4 times a, which is 1, and there should be a 1 there, negative 6 all over 2 times 1. I did it quickly. I think the numbers are putting quickly. I think they're correct. This is going to be a positive 2. This is by quadratic formula. Plus minus square root. Now, underneath that square root can get tricky. This much is 4. Anyone tell me, and be very careful, what is the remaining part going to give me? this part underneath there. Is that 24?
Yeah.
I think it's 4 times is positive 24. Now this is my quadratic formula, same problem, but not quadratic formula. All over 2. Now it's going to be 2 plus minus, I think that's square root 28. All over 2. Too bad it's not 25, it's not. Does anyone think they know what 28, square root 28 looks like simplified? It's not perfect.
2 root 7.
2 root 7. Exactly right. All over 2. And then what would you do to finish up and make it look nice? Can all those numbers be simplified, reduced down by 2? And you end up with 2 divided by 2 out front 1. 2 divided by 2 in front of that radical 7 is also a 1, so 1 radical 7 understood. All over 1. So you got 1 plus minus radical 7. Did we get the same answer earlier by completion of the square? I've got a break coming up. Any questions, guys? Anything at all right now? I know from what I chat you're saying, Professor, all this is going to be on the quiz Wednesday? Yes. And a little bit more. You'll see that a little bit more after the break. Okay? But I think we've done the major part already. Okay? Let me do a quick count because I do take attendance every day. Mr. Park, would you do just a count, see how many students are here?
Okay.
Just see how many students are here. And we'll get that. Just count them for me, would you? How many?
34.
34?
Mm-hmm.
Oh, no. Someone's absent. Two people walked out. They left?
Yeah.
Or maybe they're trying to add the class. They saw that from the hospital, so they walked out.
They were here,
Oh, they were here earlier?
they were here last year.
Okay, okay. Dropped out. Okay, guys, so I'll do attendance again after you get back. Guys, take your 10-minute break.